What is going on, guys? Welcome back. In today's video, we're going to learn how to implement an option trading strategy or an option trading bot in Python. So let us get right into it.
Not a game, it's a redskin.
Alright, so for this video today, in order to implement an automated options trading strategy, we will need to have some options data so that we can apply the strategy onto the data. We can analyze the strategy using the data. And for this, we're going to use the platform ThetaData, which is also the sponsor of this video today. And this is a professional platform that provides stock data and options data using the low latency API. In other words, this means that we're going to get the data very fast and we're going to get it with a minimal delay. And this platform offers real-time data as well as historical data. So we're going to be able to backtest our strategy. And the good thing about this here is when you go to the pricing tab, you can see there is a free tier. So you can follow along with the video without having to subscribe to the service immediately. We're going to build, first of all, a trading strategy using the end of day data that is available in the free tier. And we're also going to then implement a more advanced strategy using some more granular data with one of the paid tiers that you can see here. So this is what we're going to do in this video. They also have an API with the documentation, so you can go to the tutorials tab and you can see how to install all of this. We're going to do it here in this video as well. So the first thing that we want to do is we want to open up a command line and we want to use pip to install ThetaData. So pip install ThetaData, and depending on your operating system, maybe you will have to say pip3 install ThetaData. Just make sure you get the latest version because this is constantly being updated. And then we can just go into our Python development environment and we can start by importing from ThetaData. We can import the Theta client. This is the most important thing. This is the thing that will allow us to connect to the API. We're going to also import the option request type, so option rec type. We're going to also import the option write. We're going to import the date range, and I hope you can see that, and my camera is not blocking all of this, so I'm going to just shift it down here. And we actually don't need anything for the stocks. Now, the API also offers stock data, but our trading strategy will not be based on the stock data, so we're not going to do anything with stock data here. But what we also need to import is we need to import pandas as PD. We're going to have to import matplotlib .pyplot splt, and we're going to import from core Python datetime as dt. And obviously, if you don't have pandas or matplotlib installed, you will have to install those as well. So you open up your command line once more and you type pip install or pip3 install pandas and matplotlib like this, and then you have the libraries you need. And with those imports here, we can now build a simple options trading strategy. And the basic idea of the strategy is to look at trades, to look at option trades, and to find unusual trades by looking at the volume or the size of the trades, depending on whether we're using end of day data or the more granular data. We're going to just look at unusual transactions or unusual days, and we're going to buy when we have a lot of volume for the call options, and we're going to sell when we have a lot of volume for the put options. That's the basic idea. We're going to also evaluate the strategy, so we're going to see for certain time periods with a certain ticker symbol, is the strategy profitable or not? That's the basic idea. So we're going to start with a simple function called create signals. And this function is going to generate our buying and selling signals. And we need to pass to this function a ticker symbol, an expiration date, and also, the client itself. So we're going to pass the client into the function so that we don't have to constantly open up new connections. And the basic idea when doing options trading is you have an expiration date and you have strike prices. So for one given expiration date, you have multiple strike prices, and you have different prices of the option itself. And what we essentially want to do is we want to pass a ticker symbol of a company, and we want to then go through the different expiration dates and through the different strike prices, and we want to apply the strategies onto the different combinations, and we want to see if we would be profitable in certain scenarios. That's the basic idea of our backtesting here. And what I'm going to do here to gather all the transactions is I'm going to create a dictionary transactions, And the fields of this dictionary, and the basic idea is that we're going to then take this dictionary and turn it into a pandas data frame. We're going to just say we have the transaction date field. We're going to have the ticker symbol, even though that is going to be the same all the time. We're going to have the strike price, or the strike prices. We're going to have the expiration date. And we're going to have the transaction type. So in our case, this is going to be either buy or sell. All right, so this is our empty dictionary now. And what we're going to do now is we're going to use the ThetaData API to get the information first. So we want to get the option data and we want to find unusual data. So what we're going to do is we're going to say strikes. And we're going to assume that the client has already been connected, so we already logged in. This is one thing that you need to understand about the ThetaData API. You can use the free service without creating an account. So you can just create an instance of the Theta client without having an account yourself. You can just log in without, or you can just not log in and use the API, but then you're limited to very few requests. So what you want to do if you want to do this, if you actually want to implement a useful options trading strategy, you want to create an account and you want to log into that account. I'm going to show you here once we're done with the functions how to do that. But let's say the client is already initialized. Then we're going to say client.getStrikes. And we're going to get the strike prices for the given ticker symbol. So the ticker symbol is basically just an identifier of the underlying asset. AAPL for Apple, TSLA for Tesla, and so on, FB for Meta or for Facebook. And we'll also want to pass the expiration date. So for this combination, we're going to get all the different strike prices. And we're going to say now for strike in strikes. So for each strike price, we're going to go through an iteration and we're going to try to get the data. We're going to say the data is, and here we're going to make a historical option request. So we're going to say client.get_hist_option. And here we need to pass a couple of fields. So first of all, the request type. So rec equals, this is going to be option rec type dot end of day. This is the only thing that is supported with the free account. So this is data for each day with open, high, low, close volume. So we're going to apply the strategy to this first. Then we're going to specify the root, which is going to be the ticker. Then we're going to specify the exp, which is going to be the expiration date. Then we're going to specify the strike price, which is going to be the strike price. And then we're going to say the right of the option. So what type of option are we actually looking at? We want to find call options. And we want to say that the date range is essentially the expiration date. But we want to look 90 days before that expiration date. So we want to have 3 months of time to apply the strategy. So we're going to say DT time delta 90. So this subtracts 90 days from the expiration date up until the expiration date. That is the date range. And we need to turn this into a date range object. So date range like this. Okay, so that's the basic idea. We're looking for an end of day data for call options for this combination of this ticker symbol, this expiration date, this strike price in that time frame. This is the data that we get. We will get a pandas data frame with open, high, low, close data. And essentially, I think it would make sense to actually print this before we proceed with the strategy. So I'm just going to add an except block here. I'm going to continue. But I just want to show you what this data frame looks like. So we're going to just print the data without doing any of the trading yet, without doing any of the strategizing yet. We're going to create an instance now of the ThetaData client. So we're going to say client equals Theta client. And we can actually do this without a login, I think, because we're using the free platform here. And I'm going to just say now with client.connect, I'm going to say ticker equals, and we're going to use just BMY as the asset here. And we're going to say the expiration dates that we want to look at are client.getExpirations for this ticker symbol BMY. And we're going to say for expiration date in exp dates. And I'm going to just use iLog here to slice or actually this is a list, so we don't need ilog. This is not a panda series, so we're going to say from 390 up until 400. So those are just 10 dates right in the middle. And we're going to say here, just call the function. So we're going to try to call the function create signals on the ticker symbol with the expiration date and with the client. And except we're going to just continue. So that should be it. This is not a strategy yet. We're just looking at the data. So you can see here, you're currently limited to 20 requests per minute because we're using the free version here. I think this should still work without a problem. We should be able to see the data frame here. So this will just take some time. It should print the data every time. Or maybe it's getting exceptions. That could also be a problem. Let me just see if it gets exceptions. We're going to say exception SE, and we're going to say STRE, print STRE, just so we see if there are any exceptions that are preventing us from running the code. Insufficient permission. Okay, so I think the time frame is maybe too far in the past for the free account. So let us just log in here real quick. And we're going to say here the username, in my case, equals accounts@neural9.com. And the password is going to be read from a file. So I'm going to open up the sec.txt file on my computer in reading mode, and I'm going to read the content from it. So this should then be enough to perform the request. And then we should see the data frame, which shows the structure of the actual thing. There you go. So sometimes you're going to get no data for contract, which is fine. This is just an exception. We just skip over it. But if we have data, you can see the structure here is open, high, and actually we have low, close, volume. We also have the date. So we have here a data frame with information for the individual trading days here. And this is what we're going to analyze essentially. So let's keep this down here. Let's also keep this, but we're going to continue to implement this strategy here. So we're going to not print anything. We're going to just continue so that we don't get a bloated output. And instead of printing the data frame, we're going to now apply our strategy onto the data frame. We're going to say, first of all, we want to have enough data. If we just have 2 instances here, it doesn't make a lot of sense to look at the average volume and to look at standard deviations because that's just too little data. We're going to say the length of the data, so the instances, the rows have to be more than 10. If we have more than 10 rows, we're going to generate signals. We're going to say, first of all, because the column names are data.type.close or something, I want to have them simple. So I'm going to say here, data columns are going to be equal to open, high, low, close, volume, count, and date. So just simple columns that can be understood quite easily. And then we're going to say data.setIndex. We want to have the date as the identifier. We're going to say inplace true so that it's automatically changed. And then we're going to generate the signals now. So data signal is going to be data volume. And the basic idea, as I said, is we want to look at unusual trades. So we're going to look at the volume and we're going to see whether the volume of this particular trade is larger than the average, than the mean, plus 3 times the standard deviation. And of course, you can tweak that parameter. You can maybe say 4 times, 2 times. You can play around with the parameters and see what gives you the best results. But our check for generating a buying signal now is going to be the volume has to be larger than the data volume mean plus 3 times the data and then volume.std. So we get the standard deviation of the volume 3 times, and if we're 3 times above the mean, then we're going to generate a buying signal because that's an unusual trade. That's how we define it here. And then we can say selected data is going to be data data signal. This basically gives us now all the instances where a signal was generated, because this is just a true or false, a binary feature now. And here we just say, give me all the instances where we have a signal where this is true, essentially. And what we want to do now for these selected instances is we want to iterate over them. So we want to say for index and row in selected data iteros, we're going to iterate over the rows. We're going to say now transactions, and we want to fill up this dictionary here with the respective data of these instances. So transactions, transaction date is going to be equal, or not equal, sorry, we're going to append to it the date, which is in this case the index. And then we're going to copy this a couple of times, and we want to change this from transaction date to ticker. We want to change this from transaction date to strike. We want to change this from transaction date to expiration date, and this to transaction type. And here we're going to then say row, or actually not row, ticker, strike, expiration date. So those are the things that we already have. The ticker is defined here as a parameter, expiration date as well. And for the strike, we iterate over the strikes. So those are not part of the data frame. And the transaction type will always be buy. So that's the basic idea. We go through all the signals. Maybe let's recap. We download the data, the historical data, and we say, okay, if we find traits or days where we have a volume that is 3 times or 3 standard deviations above the mean, we're going to generate a signal. For all the rows where we generated signals, we're going to append their data to the transactions dictionary so that we have something that we can turn into a data frame. And then what we're going to do is we're going to basically repeat the same process here, so we can actually copy this. We're going to stay in the for loop. So we're going to, let's just select this here. We're going to stay in the for loop, but we're going to do the same thing essentially for put options now. So this is now, is this on the same level? Yeah, it is. The basic idea is we're going to do the same thing, but we're going to change call to put, because we now want to find also unusual traits for put options, because that will generate a sell signal. We're going to look at the call options, unusual call options, transactions to generate buying signals, but we're going to sell if there's an unusual volume for the put options. And for this, all we need to change is, I think, this to put, and then we need to also change this here, obviously, to sell. The rest is going to be the same. We're still checking for the same thing. The data is still in the same format, but now we're just doing the same strategy for the put options, and we're generating selling signals. So that is basically our generate signals method or function. The only thing that we need to do now is we need to turn this into a data frame. So at the end of all this, once we're done with all the strike prices, once we're done with all these combinations here, we're going to go at the end and we're going to say pd.dataframe. Based on the transactions, we're going to generate a data frame, and this will be exported to a CSV file, which we're going to call transactions.csv. And this file will be used by our second function, which is going to be used for backtesting. So we're going to define a second function, which we're going to call backtest. It's going to also take the ticker, the expiration date, and the client. And this function will now basically take all these transactions, go through the historical data once more, and see what would happen if we buy here, sell here, buy here, sell here, and it will analyze the profit of our strategy. So we're going to say here that the data frame will be loaded using pd read CSV from the created transaction CSV file. So this function can also obviously then evaluate manually created data. So if we create this CSV file here manually or with a different script or something, we can still analyze it with that function because it just loads it from here and then it applies the strategy. So data frame is the data frame, and then we're going to sort this data frame. So we're going to say sort values. We're going to sort it by transaction date so that it's in a continuous order, so that we have not buy, sell, but we have this on a time series. And we're going to say the index of this data frame will also be the transaction date. In place equals true, so that it's applied. And then we're going to drop, for some reason, when we import this, this will have an unnamed column. Since I have prepared the code, I know that this is the case. This will have an unnamed column for some reason, and we're just going to drop this. So we're going to say drop unnamed 0. If for some reason you don't have that, just don't drop it. So if you run the script and it tells you, okay, there is no column unnamed 0, you don't have to drop it. In my case, it creates it. I think it will do it for you as well. But if not, you can just not drop it because it's not there. In my case, I'm going to drop this in place true, access 1 to specify that we're dropping a column, not a row. And once this is done, we can extract the strike prices by saying strikes equals df, or actually sorted set df strike values. What's the idea behind sorted set? When you apply the set operator or the set function onto a list, you get each value only once. So if you have 6 times the value 65, it's going to give you only one instance of 65 because in a set we have no duplicates. And turning this into sorted gives us a list again, so not just a set, but a list. And this list is also sorted. That's the basic idea here. And now what we're going to do is we're going to backtest. We're going to say that the total profit of our strategy is 0. We don't have any profit. And for strike in strikes, we're now going to say data equals, and essentially we're going to copy this here, the first request that we sent to the API. We're going to do this, and we're going to now go date by date and see what we're going to see what buying and selling would produce for us. So we're going to say again, data columns equals open, high, low, close, volume, count, and date was the last one. And then data set index is going to be date again. In place equals true. And now we can do two things. First of all, we can visually represent the trading signal. So we can plot the individual trades with a green and a red marker to see visually, okay, we bought low, we sold high. That would be one way, or we could just add the data to the profit. So we can just calculate the profit as a number. And we're going to do both here. So we're going to say here plt, which is matplotlib, plot. And we want to plot the data itself. So data.index against data.close. This plots just the date against the close. So we're going to have a continuous, on a time scale, we're going to have the closing price, how it develops. And then we're going to plot now the buy data. So we're going to say buy data equals, and it's going to be, buy data is going to be df, where the df.transaction type is equal to buy. And we're going to say buy data equals buy data, but we only want to get the data for the specific strike price that we're currently looking at, not all the strike prices. So we're going to say buy data dot strike equals strike with 2 equals, obviously. And then we're going to say the filtered data is going to be the data index. So the date has to be in, and we're going to say buy data index. So the basic idea is we're just looking at the dates. We're just looking at the data where the dates also have buying signals in the filtered buy data. So we're getting the data frame, we're getting all the buy transactions, all those for the specific strike price, and then we're limiting the data to only have the dates where we have buying transactions. That's the basic idea. And now we're going to scatter those by saying plt scatter, and we're going to say filter data.index on the x-axis, filter data.close on the y-axis. The marker is going to be a V, so a downwards triangle, and the color, actually, sorry, this is for the selling. It's going to be a head, so an upwards triangle, and the color is going to be green, indicating that a buying transaction happened at this particular point. And then we're going to copy this, we're going to paste it down here, and we're going to just do the same thing for the sell data. So the sell data, we're going to replace the buy data here with sell data. We're going to replace buy by sell. And other than that, we're going to replace this to a V, so a downward triangle, which is red for the selling. and this will then give us the selling signals. We can show this, PLT show, to get a visual representation of our strategy. And what we're also going to do is we're going to calculate as a number these results. Now, I'm not sure if this is already going to work. It's not going to give us a number, obviously, but maybe this will already work to get the visual results. Let's see if that's the case. So we're going to just call backtest after calling create signals. So this basically first creates the signals, exports them to the CSV file. The CSV file is loaded by backtest, and backtest then goes through the individual strike prices for the expiration date and ticker combination, and then it plots the transactions without giving us any metric to evaluate then the profit. But if this already works, if I didn't forget anything, this should be already showing us the graphs with the triangles saying, okay, you bought here, you sold here, and then we can visually already see, okay, am I always buying low and selling high, or am I always buying high and selling low, which would mean that I lose money. But I'm not sure if this is going to give us the results already. But we also don't get the exceptions, so maybe let's just restart this here. Let's say exception SE. I'm always doing continue because in the end result, we don't want to see all the exceptions because we're going to get quite a lot of exceptions that are not really relevant, like no contract data found. But for the troubleshooting, for the debugging, it's always reasonable to print the exception. So print STRE here. Here we don't have a try catch yet. And here we're going to also just say print STRE. Let's run this again and see if we have some errors that might be caused by bugs. But yeah, this is the idea of visual backtesting. For the actual number, we're going to have to go through the individual instances for the strike type. We're going to see, okay, if there's a buy, add something to my balance. If there is a sell, remove it from the balance, or actually vice versa, because when you're buying, you're spending money. So you're removing your money when you're doing a buying transaction, you're increasing your money when you're doing a selling. There you go, we have some data. So here you would see, in this case, we don't have a selling signal, we only have buying signals. And you can see one buying signal would be here, one would be here. And if we don't have any selling signals, we're just going to evaluate on the latest price. So to make the calculation, we would say, okay, we buy one here, we buy one here, and then we would just say we sell all of them here, and we would calculate the profit. And you can see we have this for different strike prices. So here we would just buy here. Here we would buy here. We don't have selling signals yet. Here we would have a selling signal. So here we buy one here, we buy one here, we sell one here. And in this case, here we would lose money, but here we would gain money. So we would have to calculate how much money we gain or lose. And obviously, as always with strategies, with finance, you can never guarantee that a strategy will always make you money. If that was possible, people wouldn't study this profession. You would always have to, yeah, you can see here how this looks visually. But no strategy on earth, at least there is no strategy that is known to the public that can make you money every time. So no matter how good the strategy is, you will always lose money in some cases. But this strategy will look quite promising, as we will see here with the backtesting. So we're going to now calculate the actual profit. We're going to say amount owned is going to be 0, and then the profit is going to be 0 as well. And then for index row in df strike has to be equal to strike. We're going to iterate over the rows here, and we're going to say if the row dot transaction type is a buying transaction, if that is the case, we're going to say we own now one option more. And for the sake of simplicity for this strategy, we're going to always just buy one when we have a buying signal, and we're going to sell everything when we have a selling signal. That's the basic idea here. And we're going to say that the profit is going to be decreased now because we're spending money to buy an option. So we're going to say the data index, where we have this particular index. We're going to get the close price of this, the actual value, so values index 0, and this is basically giving us the price now. So this is what we spent to buy this option. So we now have one option more. We spent this amount of money to acquire this option, and on the other hand, if we if we say, actually we just have to say else because we don't have any other transaction types, but if it's not buy, but sell, what we're going to do is we're going to say if we have any, because oftentimes we might get a selling signal before we actually have anything. In this case, we just want to do nothing, but if we have more than 0 options, we're going to say profit is going to be data, and then data index has to be this index again. We'll look at the closing price and the values, but this time we're going to multiply this price. Let me just add an additional equal sign. We're going to multiply it by the amount owned because we're going to sell everything. So we have X amount of options. We're going to sell all of them for the current price at the time of the selling signal, and then we're going to set the amount owned to 0. That is our basic strategy. And all we need to do after this is we need to say profit plus equals amount owned times data ilog -1. So getting the last instance, and we're getting the closing price of the last instance. And the basic idea here is that if for some reason we haven't sold what we have, we're just going to say, okay, we get the close price of the last day to say, okay, you bought, you never sold, now you're going to sell, this is the price. So that will also be added to the profit. We can then print the profit by saying, let me add here an F string. The profit is going to be round profit to 2 decimal places. And then the total profit, which is, think about this profit here is inside of a full loop that is just for one specific strike price. The total profit will be for all the different strike prices given a certain ticker and expiration date. So now we're going to say total profit plus equals profit. And then outside of this loop, we're also going to print the total profit once more. Total profit is going to be round total profit 2 decimal places. And that is basically the backtesting strategy. I'm not sure if we haven't created any bugs, but we're going to just run this now. We can run this with the graph, which will, require us to click through the different graphs, but we're going to see now how this strategy performs using the end of date data. From this time frame, I picked this time frame because it's, I think, 2019 up until 2020, some like 3 months or something. But this is just not 2012 or something, which is too far away, and it's also not too recent. But here you can see now we have this strategy. We buy here, we sell here, essentially everything. If I close this, you can see the profit here would be 3.86. So this is positive. And you can see here the scale on the side. Here we would buy here and sell here. This would also give us a profit of 3.65. Here we buy here, we sell here, 2.67. Now here we buy here, we sell here. This gives us also a profit of 6.24. Here we should have a loss because we buy here, we sell here. Okay, this actually gives us a profit. Why is that? Maybe it does give us a profit. But in this case, let me just see something where we obviously lose money. Here, for example, here we should lose money because we buy here and we sell down here. So you can see we have a negative profit. Yeah, so you can play around with that, and you can then, in the end, maybe if we don't show the graph, we're going to have this faster. So we're not going to have to click. We're going to see the total profit quite quickly. So we're going to just get profit, and then total profit. And we can see if for this expiration date and this ticker symbol, we would have a profit with this strategy and how high it would be. So let's just let this load here. No data, no data. There you go, profit. And then all of this will be added together to a total profit of 17.64. And then it would continue to go to the next expiration date. It would create the signals again. It would backtest again. You can see no data for contract. And that is just buying one option every time we have a buying signal and selling the option or selling all the options when we have a selling signal. You can, of course, tweak this. You can say, okay, I want to buy 5 options. I want to buy as many options as I can with the money I have, or I want to sell only 50% of the options. Here you can see now we would also have a small profit here, and you can just go through this. This is the backtesting part. You can play around with different ticker symbols. One thing that might make sense here is you don't want to go with the mainstream ticker symbols like Tesla, Apple, Facebook. You want to go with some more unknown or some more niche companies or ticker symbols, because there you will find inefficiencies probably easier. So if you find unusual trades there, this might be more promising than if you do it for Facebook, or maybe you won't find them for Facebook. Yeah, so this is with the end of day data. So the strategy we just implemented works on a day-to-day basis. For each day we have open, high, low, close. We're working with a close price, which is the last price of the day. And that is fine, but if you do actual options trading, you probably want to look at individual trades. So you want to have more transactions per day. You want to look at more granular data. And for this, you can use the request type, not EOD, not end of day, but trades. So this is for professional trading signals, and this is part of the premium API. I'm not sure if you get this already with value. We can just click on this. Okay, you get it with the standard tier. So if you want to use the trade signals, you would have to go for the standard tier. This is the third one here. And with this, you can get more granular data. And all we need to do here to change the strategy to work with this is we need to change the column names. And we need to, because the data frame that we get here from the API has a different structure and different column names. So we're going to first of all change all these request types here to trade instead of EOD. So we're going to go down here, trade. We're going to go down here, trade. So for backtesting and for creating of the signals, we're going to use the trade data now. And instead of having open, high, low, close, volume, count, date, we're going to change this to be MS of day. We're not going to use this actually here. We're going to have sequence. We're going to have size, which is basically our new volume now. We're going to have condition. We're going to have price, and we're going to have date. So the price will be our new close. The size will be our new volume, and the date will still be date. So we're going to still set the index here to date. Instead of checking now for the volume that has to be 3 standard deviations above the mean, we're going to check for the size that has to be 3 standard deviation of the mean size. So this needs to be changed here. And then down here, we need to do the same thing. So I can just copy this here and paste it down below. And here we're also going to say again, size, and size. Because now an individual trade has an unusual size, not a day as a whole has an unusual volume. So that is that. This is the create signal function now. And then for the backtesting, we need to do the same thing. So we need to also change the columns again. And we're going to say here now that we're not looking at the close anymore. We're looking now at the price. So this is the new column name. So we have to change close to price here as well. Price. And I think we shouldn't have volume here anymore, but we have some close instances here. So price. And I think that is actually it. This is all we need to do to make this more granular and use it with the advanced trading signal. So let's run this. Maybe let's also run this here with the graph at least one time. And this will then show us now, again, visually how the individual trades are performed. And we should have basically the same visualization and different profits, because we're now trading on a different basis. We're not just looking at one day as a whole and evaluating the volume and then buying the close price. We're looking at individual trades, and we're then okay, no, this is not. There you go. Here we have a buying signal, and here we have a couple of buying signals, a selling signal, a buying signal. But let's actually just print the profits here just so we see the difference in the numbers. So let's just comment this out again and let's run this to see what the profits look like. And with the previous strategy, with the end of day strategy, if you run this for some time, you will see that most days are profitable. Some are very profitable, some are slightly profitable, some are unprofitable. But the strategy seems to work for that ticker symbol in that time frame for the different expiration dates and strike prices. It's not always the case, but here now you can also evaluate this strategy. You can see we have quite some profitable trades here. The total profit for a given expiration date for the first one here is 27.74, which is quite high. I think this was higher than the EOD strategy, and you can run this now. I think some days were unprofitable in the beginning. I ran this already to prepare the video, but here we also have again a profitable day, a profitable instance. We can let this running. We can leave this running now for 2 more expiration dates. But this is how you do the back testing. And what you would do now to do this as an actual trading bot, to implement this as an actual trading strategy, would be that you go and use these signals in real time to perform the trade. So here you can see a very profitable day. You would use these signals to then say whatever API you're using .buy. Now, ThetaData at the moment doesn't offer buying and selling, so they don't have the possibility where you can actually perform a buy. They can generate signals, you can use the data, you can analyze the data. You have many different functions that you can use. You can all see them. You can see them all in the reference here. So you can click on reference and you can see all the functions they have and the documentation for that function. But they're not offering currently the ability to actually do a buy or a sell. So you would have to connect to your current options trading platform and you have to buy and sell using that platform. But you can use this structure here, this algorithm, this strategy here, and ThetaData to create the signals real time with low latency, and then you can buy or sell and do the actual stuff with the API that you're currently using. Alright, so that's it for today's video. I hope you enjoyed it and I hope you learned something. Don't forget to check out ThetaData. The link is in the description down below. You can sign up for a free account. You don't have to pay anything. You can play around with the free tier. The only thing you don't get is you don't get real-time data and you don't get access to expired options. So you would have to apply the strategy to options that are currently still active, so you cannot really do some proper back testing, but you can apply the strategy that we talked about in today's video. And if you want to do some professional trading, you can also sign up for the value standard or pro tier, where you get many different request types and you get real-time access and you get support and all that. But make sure you check them out. You can start with a free account to play around. Also, if you like this video, let me know in the comment section down below. Let me know by hitting a like button, and don't forget to subscribe to the channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.